So today we're going to be going over non-contact 2D and 3D surface measurements for gear surfaces. All right, so just a quick overview of today's presentation. First, we're going to go over ZYGO's technology. So we're going to be looking at our optical profilers specifically. Then we're going to get into what's driving new gear processing methods. Then we're going to look into producing a polished gear. Then we're going to get into some of the actual metrology, and we're going to be looking at texture parameters used to characterize the gear surfaces. Then we're going to do a quick live Q&A break. Then we're going to get into setting things up with our ZYGO profilers, and we're going to be looking at the gear measurement setup and sequence. Then we're going to do another quick live Q&A break. And then we're going to get into using ZYGO software successfully in a production style environment. And then we're going to wrap up and do one more live Q&A session. So today there's going to be three ways that we're going to answer any questions that you may have. One being answering it during the live Q&A portion. Two, I have two colleagues, Kyle Deldana and Michael Schmidt, sitting with me live here, and they're going to be answering questions via the GoToWebinar interface. And if you have a more complicated question or we don't have time to get to your question during the webinar, we'll answer it via email afterwards. So let's look at the ZYGO technology overview. So at ZYGO here, we're going to give you the ability to provide 3D topography maps of all types of machine surfaces. We're going to give you those traditional 2D standard parameters, but there are some additional capabilities when looking at 3D plots. Some of those additional capabilities are 3D surface form, large area inspection, volumetric results, and defect analysis. And what's nice about these 3D area plots is we're providing you with a lot of data. So at a minimum, we're looking at 1 million data points per data set. So here's a quick graphic of how the objective scans. So you'll see we have the interferometric objective, and it's scanning down in the Z direction. And the goal is to find the peak contrast in the interference fringes. So I'll show that animation one more time. And we'll see that signal A's peak contrast envelope is going to come in before signal B's, and that's due to the difference in height. And we're going to use these contrast envelopes to show differences in height and create surface maps of the entire surface. So here's a quick little tutorial. So here we see those interference fringes coming across the screen. When they're in their peak contrast, that's when we're going to see that contrast envelope, and that's how we're going to acquire the data. And then we're going to use this data to create a 3D aerial surface map as shown here. So it's really as simple as that. So next, let's get into what's driving new gear processing methods. So we're seeing a big shift in the automotive industry from internal combustion vehicles to electric vehicles. And this is even obvious to the everyday consumer. So 10 years ago, when you went to go shopping for groceries, you wouldn't see an electric vehicle in the parking lot. Now, when you walk into the grocery store, you'll see 10 separate electric vehicles at charging stations. So it's even obvious to the consumer that there is a big shift in the automotive industry. This shift is being driven by regulations on emissions reduction and consumer demand. So to meet these demands, automakers are shifting to producing and manufacturing more robust gears with tighter tolerances. So again, we need higher quality gears to help fulfill new emission regulations and consumer demands. Gears can help with the emissions regulations by potentially helping with higher efficiency in the vehicle's performance. To meet consumer demands, having higher quality gears will also reduce the in-cabin noise in the vehicle and give a smoother ride to the consumer. So first, let's look at addressing gear efficiency. Smoother gears can fulfill increased drivetrain efficiency requirements. So that's going to lead to possible increase in vehicle range. We're going to do this by achieving lower surface roughness requirements, but having these lower surface roughness requirements is going to potentially require new manufacturing methods or processes. So to meet these new specifications, new metrology methods such as non-contact will be required. And of course, this is a method that ZYGO is going to provide, and the technology that ZYGO will provide. So now let's look at addressing gear noise. Without an internal combustion engine, gear noise can be prominent in the passenger cabin. So without the extra noise from the engine, these noises due to the gears coming in contact can be much more obvious to the consumer. So it's become a key task for auto producers to reduce noise for passenger comfort and safety. So the demand for higher quality gears is going to require new manufacturing processes, and these new manufacturing processes are also going to require new qualification methods. So we're looking at more high quality, higher value parts when we have these smoother gears with higher tolerance, with tighter tolerances. So it's going to be a lot more critical to measure without damaging the surface. Traditional methods might require marking or coming in contact with the surface. And when you have a high value, high quality part, this might damage the surface and render it useless. We're also going to be able to provide more insight into the surface texture. So with 3D aerial data, you're going to be able to look at defects and micropitting that traditional 2D parameters may miss. And then this method is also going to be quick and precise. So ZYGO is able to offer repeatable and reproducible results. So therefore, our ZYGO inspection technology may be best suited for the evolving manufacturing processes of gears. So we offer a suite of optical profilers. Our desktop solution is the Z-Gauge, and our flagship system is the NextView NX2. What's nice about the Z-Gauge is it can be placed right on a tabletop and can take and give you quick results. The advantages of the NX2 is it's fully automatable and programmable. So this is going to be what we offer your turnkey solutions for. You can have an operator come up, one button click, and it will give you all the results you need to make decisions on your manufacturing processes. Also, the NX2 can be placed in the Guardian enclosure, and this enclosure can be placed right on the production floor. So you can put it right next to a mill, right next to a lathe, right next to a grinding or polishing tool. You can do that polishing process, take a measurement of the gear, look at some results, and see if you need to make any changes in your tooling and manufacturing processes right live on the shop floor. So let's look at producing a polished gear surface. To produce ground or polished surfaces, gear manufacturers use a series of steps. The first step is going to be roughing, and this is going to establish the primary shape of the gear and gear teeth. And then the second step is going to be grinding or polishing, and this is going to establish the gear tooth surface texture. And this is going to be the critical step to have the final quality of the gear surface. So here in the grinding process, it's going to provide the initial texture for the gear surface. So we'll see the ground gear tooth here. And we'll see that we have these peak asperities. The goal in the polishing process is going to actually be to remove these peak asperities while keeping the void valleys. So the reason we want to keep these, we want to remove the peak asperities is to create that load-bearing surface. And we want to retain the valleys for lubrication retention. So understanding the surface roughness leads to a better control of the process and potentially will increase the efficiency of the gear system. There are certain manufacturing processes that are going to affect the surface roughness, two being the tool tip and the feeds and speeds. The polishing process will establish the gear surface texture. And again, as mentioned on the slide before, we want to keep those void volumes while getting rid of the peak asperities to create that load-bearing surface. So understanding the waviness of a gear surface can decrease the noise. Again, there's a couple of manufacturing processes that affect the waviness, two of them being the distance changes between the tool and the part and non-rigid fixturing. So understanding and quantifying waviness allows a manufacturer to control these processes. And with almost immediate feedback from metrology, we can reduce part scrap or tooling issues. So next, let's look at texture parameters used to characterize the gear surface. So again, the parameters or the surface features that we're looking at are waviness and roughness. The waviness is going to look at the widely spaced irregularities, while the roughness is going to be looking at the more closely spaced irregularities. And you can see that in the image here to the right. So ZYGO's MX software is going to provide automatic filtering. And this filtering is useful because we can provide filter cutoffs to cut off for the roughness wavelengths and to cut off for the waviness wavelengths. So the shorter wavelengths signify the roughness, while the longer wavelengths will signify the waviness in the data. So some parameters that we can use to describe surface roughness are going to be SA and SZ. SA is the average roughness evaluated over the areal surface, and the corresponding 2D parameter is going to be RA. SZ is the maximum height of the areal surface data, or the peak to valley, and the corresponding 2D parameter is going to be PV. Now, the parameters used to describe surface waviness are going to be mathematically the same. They're just going to have a different naming convention. And the reason for this different naming convention is to know that the data is associated with data filtered for waviness. So WA is going to be the same as SA or RA. And WA is going to give us the average roughness evaluated over a 2D profile. But again, that W is to signify that the data is filtered for waviness. And then WT is going to be similar to SZ or PV, and it's going to give us the maximum height of a 2D profile surface or the peak to valley. And again, the W is to denote that the data isn't associated with roughness and that the data is associated with data filtered for waviness. So we're also able to provide additional hybrid parameters to quantify surface tribology. So as mentioned before, the goal is to minimize the peak asperities while keeping the void valleys, because we want that load-bearing surface, but we also want lubrication retention. So we can use variables and parameters such as RPK, RK, and RVK to assess how many peak asperities are still on the surface and how much void valleys we still have. So now we're going to get into a quick Q&A break, and I'm going to see if Mike has any questions from the audience.
So far, we have one question. Are there ISO standards now for 3D measurements?
So that's a good question. So yes, they were published in 2012, and we do have ISO standards for 3D aerial parameters, and they're going to be under ISO 25178. And if that's our only question we have for this break, I'm going to move on and get into the next section. So gear measurement setup and sequence. So now we're going to be looking at the actual measurement setup using a ZYGO Optical Profiler. So each gear or gear system is most likely going to require special fixturing or independent fixturing. This current setup we see here is measuring from the tip to the root of the gear. We're also capable of measuring the entire gear flank surface with appropriate fixturing. So this is utilizing what's called ZYGO stitching capability. And what the stitching capability is doing is taking multiple measurements across the tip to the root of the gear, and these measurements are slightly overlapping. And we combine these measurements or stitch them together to create a measurement of the entire surface. So you'll see the actual ZYGO MX software's UI here. In this case, we're taking 5 stitches or 5 measurements across the tip to the root, and we are taking those 5 measurements, combining them, and automatically getting the data out. So with our automated and coordinated XYZ movement and our proprietary stitching algorithms, we're able to successfully take measurements across the entire gear surface. So here's another up close look at that gear tooth root to tip measurement. So we see we have that 4 millimeter length, Again, we're taking those multiple measurements with slight overlap. We stitch those measurements together. We can look at the raw data, the roughness data, and the waviness data, all through filtering. And what's nice and very impressive about this data is we can't tell that the data is stitched together. There's no seams from the stitches, and the data is continuous. We can see the roughness machining and the waviness machining all continuous without any disturbances due to the stitching algorithm. So again, we can process the data in multiple ways. Here we're processing for form, waviness, and roughness. And we're able to display the 2D and 3D parameters for form, waviness, and roughness simultaneously in the same application. So an operator can come to one screen, print out a report with all results from all different types of processes. So one other advantage of the aerial data is going to be defect analysis. So again, as the slide before showed, we can look at form, waviness, and roughness across the entire flank surface. And again, another advantage is going to be general defect analysis. And we're able to show the 3D aerial data, and it's going to probably give a little bit more information than 2D options. So here we see that we have this defect in the 3D aerial data, but none of the actual 2D profiles are going across that defect. So this is about where that defect would show up if one of the 2D profiles was going across it. However, we see that we're only seeing a peak to valley of about 4 microns. But when we look at the SZ or PV of the aerial data, we actually see that we're closer to 100 microns peak to valley. So this can indicate any defects or micro pitting that may be missed by 2D profiles. And this is critical to the overall quality and performance of the gear surface. And again, we're going to do another quick Q&A break. So Mike, if we have any questions.
We actually have 2 questions right now. The first question is, are all systems from ZYGO profilers capable of performing this stitching capability?
So all the systems are capable of performing the stitching applications. It's just going to come down to your specific application and your specific part type to pick which system is best suited for you.
And the second question is, what are the typical formats that or how reports can be exported?
So we have several different formats: PDF, bitmap, JPEG. We're also able to output in QDOS for those that have that requirement. If we don't have a standard format from our MX software, we also have the capability of using Python scripting to create different formats and to create different reports that meet different customer needs. And if those are the only 2 questions we have, I'm going to keep moving forward with the presentation. So using ZYGO software successfully in a production style environment. So when we're looking at solutions for the production floor, it's important to be able to have data processing. So again, we're able to look at roughness, waviness, and form all at the same time. We then have that defect inspection where we can look at localized artifacts or surface disparities. We then have reporting, and again, we can report in many different outputs in standard formats. And then again, we're able to output in QDOS for those that have that requirement. So looking at data processing, we're automatically able to filter for that waviness data and automatically able to filter for that roughness data. So the way the UI works here is this is the input data, this is the data being removed, and this is the output data. So you see we're filtering here, we see the spatial frequency, and we're filtering for just the waviness data. Here we're doing the same thing, but for the roughness data. And we're able to use our multi-surf application to display the results all at once. So again, defect analysis, we're able to use ZYGO's MX Metrology software to automatically determine defective parts based off of defects. So this specific image on the right highlights the amount of material pullout on a hypoid pinion bore ID. and we're able to output these results in different formats or integrate Python scripting if necessary. So we see in this image to the right, we have multiple micro-pitting and valleys in the surface. We're able to use ZYGO's MX software to isolate these defects and look at them individually. So we can look at them individually for any type of parameter that we would be able to look at for the entire surface map. So application ease of use. All applications can be designed, can be given a turnkey design. So basically the way this application is set up, all an operator would have to come in here and do is click measure, and then it will automatically perform that measurement and automatically output all the necessary parameters and tolerances. So we're able to set it up as a go, no go criteria. You'll see here the red is going to indicate that these are out of tolerance, and the green is going to indicate that these specifications are within tolerance. So another nice thing is we can transfer these applications from tool to tool. So if you have multiple ZYGO optical profilers at your facility, you can run the same application on all of them, and it should work in the same repeatable and reproducible manner. And also we have the option to do 2D barcode readers. So we can scan in the parts, have all of the necessary information integrate into our MX software, and then use that information to create a useful output report. And then finally, again, we're able to report using QDOS. So we can integrate QDOS into our MX software and give you any statistical analysis that may be necessary in your industry. So finally, thank you for joining the presentation today. If you have any further questions, you can reach us at zygo.applications@amitech.com. I'd also like to plug our next upcoming webinar on efficiently measuring and quantifying defects on surfaces more than meets the eye. This webinar is taking place on March 24th at 10 a.m. or 7 p.m. Eastern time. And you can sign up for this webinar on our website, similarly to how you were able to sign up for this webinar. If you've missed or want to rewatch any of our previously recorded webinars, they're all located on our ZYGO YouTube channel.